Okay, so I've seen a data definition for lists. Just to make sure we are all on the same page, go ahead and see if you can make a list containing the numbers 101, 102, 103, and 104 in that order, and nothing else. And then see if you can write an expression that extracts 103 from that list. So make a list containing 101, 102, 103, 104. I'll go ahead and pause so that you can do that. Okay. Okay, so we'll start with the empty list and we'll tack numbers onto that. So if I want to end up with 101, 102, 103, or 104, I'll start with the empty list. I'll tack 104 onto that list. Okay, great. Now I have a list that contains 104. Now I'll tack 103 onto the front of that list. Okay, great. And now we get the idea. Get that. And then finally, there we are. Okay, so this is a list containing 101, 102, 103, and 104. It contains 4 numbers, not 5 things. Empty is not something that's contained in this list. When we view it as a list, we'll think of this as just the list containing 101, 102, 103, 104. And just as a little preview to make you think, we're not going to write this in code. This is not in beginner student, but you can think of writing it this way. And you can think of saying tick, open paren, and then the elements of the list, close paren. If you like. This would be another way to think of this list, but this actually shows the structs inside the computer. Okay. How would I go ahead and extract the third element from that? 103. So if I took the rest of the list, I'll get the list starting with 102. And if I take the rest of that, I'll get the list starting with 103. And so if I take the first thing of that list, that should give me what I want. I should have a 103 sitting there. Okay, so that was just review. Let's go ahead, and I mentioned before that for this defined struct of const, the constructor is actually const, not make const. So the getters are first and rest. I will mention that there is a predicate called const. It takes in anything and says, hey, is this a list made? Is this a struct made with make const? Okay, so in particular, the empty list is not a const, but const of 3 empty is a const object structure. Okay, there is a separate function called empty ? And it just says, hey, is the thing that I'm given equal to this one very special sentinel constant tick open close? If so, it returns true, otherwise it returns false. Okay, so let's go ahead and give me a template for a list of numbers, and we'll make the template. Let's just get the split this window here, split. And I want to go ahead and keep the data definition in front of me while I do this. A list of numbers is, there we are. Okay, so now I can go ahead and have a template here. Function for a list takes in any list of, I'll call it alon for a list of numbers. Okay, it's given a list of numbers and it's going to return, well, I don't know, it's a template, so I don't know what it's going to do. Okay, what type is list of number? What type of data definition? This is a union type, this or that. 2 branches? Okay, so we should have a con with 2 branches. What questions can we use to distinguish these 2 branches? Well, we actually sort of saw, we can go ahead and say, hey, alon, are you with the empty list or are you a constructed list? And so now we can use those functions I just barely mentioned. And say empty of alon. That returns yes or no, are you with the empty list? The one empty list. And const of alon. Okay, so great, this is part of our template. Wait a minute, we had another step we just added to the template recently. If one of your branches happens to be a struct, then on the right-hand side, go ahead and pull out the fields. Okay, alon is, in the second branch, alon is a constructed list. We have 2 fields, a number and an entire other list of numbers that first one was tacked onto. So go ahead and say, hey, we have first of alon and rest of alon. Okay, and we'll have to put these together somehow and make an answer out of the first and the rest in whatever function we write. Let me just think about the types of these things, by the way. First of alon, what is the type of first of alon? It's a type of first of it. Here's our data definition. We called make const. First pulled out of the first of the two fields. Oh, it's a number. Okay, so what sort of function are we going to call on this orange selection, highlighted selection? Probably something that wants to deal with numbers, so a plus or greater than or something like that. Okay. What is the type of rest of Elan? Make const. Oh, second or rest pulled out the second field, which was a list of number. This is an entire. It's not a single number. It's an entire list of numbers, like 102, 103, 104. Okay. So we might have 101 as our first of Elan, and the rest of Elan might be const 102, const 103, const 104, empty. Okay, so what sort of function are we going to give to a function that wants an entire list of numbers? Gosh, we haven't seen any, but there's one that we have sitting on the table here. Func for list. This function we wrote up here, it wants to take in a list of numbers. Okay, so let's go ahead and put func for list right here. Okay. So this gray part, rest of Elan, is a list of numbers. We'll pass it to a function like this. What type will this return? It depends on what the function does. If the function takes in a list and returns a Boolean, then this whole gray part will be a Boolean. Okay. It would have a number and a Boolean sitting in front of us. Okay, so let's look at an example. Let's actually put this together. And the first example we're going to do is summing up the numbers in a list. So kind of boring, but give me a bunch of numbers, add them all up. Okay. Sum takes in a list of numbers and it's going to return a number. Let's do some check expects here. And we have some examples of the data we took before. So, gosh, if I have a list that contains I'll work it this way. A list that contains 4 and 3, what should the answer be? If I add up all those numbers, 7. What if I have a list that just contains 3? Well, if I add up all those numbers, I should get 3. What if I have a list that doesn't contain any numbers at all and add it up? Now, some people want to say that that should be an error. You can't add up no numbers at all. I claim I can. And here's my demo. I'm going to add up all the $100 bills in my pocket. Okay, let's go and do it. Let's get some keys, got an ID card. Oh, there are no $100 bills at all. I add them up, it's worth a total of 0. I think if you add up no numbers at all, you actually get back 0. So it's not any sort of error or undefined or anything like that. It's really, the correct answer is 0. Add up all the $100 bills in my pocket, you will get 0. I hate to break it to you. Okay. Yeah, so, hey, we have our test case for the empty list, for a list with 1 number in it, tacked on to the front of the empty list. 2 numbers tacked on to the front of the, 4 tacked on to the front of the list that just contained 3. 5 tacked onto that list. What should the sum there be? If 5 and a list that already had numbers that added up to 7, well, if I tack 5 onto the front of that list, my answer will be 5 plus 7. Carry the 2, divide by the square root, Newton's approximation, 12. Okay, so these will be my test cases. Let's go up and see if we can write this function now. Gosh, we should go ahead and take our template, right? Let's go find the template and copy paste that template. And we have to be a little bit careful here. We're going to take this template. We're going to, oops, let me unsplit. See if I can mouse correctly. Collapse these 2 windows here. I need to go ahead and replace this with sum. And make sure I replace this thing here with sum. Okay, so now here's how I want the thing to go. And this, I'm going to call this an inventory with values. Earlier I did sort of an inventory of my parts. I said I have first and I had rest, and I thought about what types they are and maybe making a recursive call. Okay, I'm going to think of an inventory with values. I'm going to think of this list const 5, const 4, const 3 empty. The list containing 5, 4, and 3. Okay. Great. What is the first of that list? 5. What is the rest of that list? The list containing 4 and 3. That is const 4, const 3, empty. What is sum of const 4, const 3, empty? So now here, what is the sum? Wait, we have a test case. It says right here, sum of const 4, const 3, empty should be 7. Okay, so as I'm looking at the template and just thinking, how do I need to approach this? I'm going to say, wait a minute. From the template, if my input were 5, 4, 3, and I want to get out 12 out of that, I'm given 7. This orange part is 7. Given sum of the rest of the list will return 7. That's my starting point. Don't try to unroll it. Just if this function works, sum of that thing will be 7, and this will be 5. How do I combine 5 and 7 to get the answer I want, 12? Well, that's not too bad. That's going to be plus. Okay. Empty list. What should the answer be in the case of the empty list? We don't have any further information. Oh, but we already worked through that thought and said that's going to be 0. Okay. So I claim, we're now done, the template. In the template, we said, hey, I had this thing here, which was a list of numbers. What sort of function might want to take in a list of numbers as an input? And we're like, well, hey, the one we're writing right now, sum. Okay, so the template suggests, hey, try. Don't always have to do it, but think of, we'll call this the natural recursive call. Okay, I'm calling sum on the rest. Why? Rest of Alon is itself a list of num, and sum wants to take in a list of num. So once I do that, I will get back an individual number. So that's where we start our thinking, with the result of the recursive call. Okay, people want to start their thinking with making the recursive call. I'm just saying, no. We're going to be given, the template gave us pieces sitting arranged out on the table in front of us. They gave us first of Alon, and they gave us the result of calling sum of the rest of Alon, 5 and 7. Sorry, 5 and 7. And I'm going to put those together to get 12. Need 2 more fingers here. 12. Something like that. Okay. So let's go ahead and I'm actually going to go through another example. We'll step through it in a moment, but here's what I want to point out is our data definition. Let's go back to that data definition because it all comes down to that. Our definition for a list of number contained list of number. And we're like, well, that's okay, but I can use this definition to actually make actual lists. I can make the empty list. I can make the list containing just 5. I can make the list containing 4 tacked onto that list that just contained 5. 3 tacked onto that list, and so on. So I can build up lists. So the fact that this was a self-reference in the data definition, and I wish I could draw an arrow from this list number back up to here, is not surprising to us, and it didn't really bother us when we went ahead and made examples of the data. I claim we're just following the data definition. The template sort of steers us this way. And so, yeah, the fact that rest was itself a list of numbers, that's what caused this function to call this function, to make that recursive call. Okay, it follows naturally from the way the data is arranged. Here's how, I'm not going to step through it yet. I'm going to phrase it this way. What does sum do when I give it the empty list? Well, I can see right now it's going to come to the con, empty of, yeah, it's going to be empty, so it's going to return 0. So I'm pretty happy that sum of empty list returns 0. Am I happy about my next test case? Sum of const 3 empty? Well, let's see, const 3 empty is not the empty list. So I'm going to fall down to this branch. I'm going to return this. What is first of const 3 empty? 3. What is rest of const 3 empty? Empty. What is sum of rest of const 3 empty? What is the sum of the empty list? Oh, we just determined that sum really will correctly give us 0, right? There's no doubt about it. Sum really will give us 0. So this will be 0. This will be 3. Our answer will be plus of 3 and 0, which is our expected answer. Okay. Well, okay, so now maybe this is maybe a little lingering feeling of doubt in your tummy. That, yeah, if I pass it the empty list, I see that works. But if you pass it const 3 empty, is this recursion really going to work? Yeah, it works just fine. What about this one? Const of 4, const 3 empty. So I'm going to pass it this thing here. I want to get 7. What will happen in the code? Think of walking through the code. I pass, so alon is this entire orange expression I have here. I'm going to take first of alon. What is first of that big orange expression? Oh, 4. I tacked 4 onto some other list. What is rest of alon? And so this is where people get confused. I'm not asking about what is, first I'll ask about what is rest of alon, then I'll ask about what is sum of rest of alon. Okay, but right now, just what is rest of alon? It's const 4, const 3, empty. So, I'm sorry, it is const 3, empty. What is sum of const 3, empty? Well, we just went through that reasoning. Sum of const 3, empty is absolutely going to correctly give us 3. Okay, so I'm going to have plus of first of alon, 4, with sum of rest of alon, 3, and get the 7 that I want. And now you can fast forward to the video if you want, but I'm going to do this one more time with the whole 5, 4, 3 empty. So what if I call sum and I pass it const 5, const 4, const 3 empty? What is first of that whole big thing? 5. What is rest of that whole big thing? This thing. Const 4, const 3 empty. What is sum of const 4, const 3 empty? We just worked that out. That's 7. So without any sort of confusion, we do know that this, if I pass it const 4, const 3 empty, I will definitely get 7 back. And this one was 5, clearly, so I really do get 12. So yeah, this is exactly what I want. And this is the thinking to do when you come up with these recursive data structures. If you have the natural recursion that just follows from the shape of the data, okay, the fact that our data definition had a self-reference down in the second field of the struct means when we're processing the second field of the struct, we're going to make a recursive call. We'll call that the natural recursion. When you have this natural recursion, start your thinking with, hey, the template says, hey, with const 5, const 4, const 3 empty, the template says I'm going to be given 5, and the template says I'm going to get the result of calling the recursive function on const 4, const 3 empty. That's going to be 7. I have 5 and 7. How do I want to combine those? And that's why we said, oh, I know how to get why 5 and 7 combined make 12. I'm plussing them. I can't believe I just said that, but okay. And that's why from the template I had filled this in with plus. Notice that how many characters are in my function sum that were not in the template? 2 characters. This became 0, and this became plus. The template did all the heavy lifting. All my work was already written out by the time I'd written my template. Okay, so this is the right way to do the template, the right way to pull things apart. We'll see some more examples, but there's going to be more examples. I'm not going to introduce more concepts or supply them different ways. We'll have functions that return, instead of returning a number, a function that returns a Boolean. We'll have functions that take in a list and maybe return a whole nother list of numbers, things like that. But overall, we have completed all the ideas present in doing this. And so what did we do? What did we add to the template? We already had a, hey, if your data definition isn't a union type with 2 branches, you'll have a con with 2 branches. Hey, on the right-hand side, if you had a struct, pull out the 2 fields. That was all there. Here's the new step we're adding to the design recipe. And I can even pull it up in the browser here. That's the top of every page is a link to recipe, the design recipe. And what we have added here is add the natural recursive call as appropriate. And we do that because think about what type each piece you have. That is, we had first of alon and rest of alon. Think about what type each were, and then say, hey, for first of alon, that's going to be a number. I'm going to call number functions on it. Okay, and that's as far as I go there. Hey, this rest of alon is itself a list of numbers. I'm going to be calling a function that wants to process a list of numbers. And the template tells me, hey, when that question comes up, think about the natural recursive call. Okay, hey, I'm defining a function for a list of numbers. I have down here a list of numbers. Think about making that recursive call. It's probably going to be helpful to us.